I'd ask you guys to look at section 4.1 and work on this worksheet 1. How did that go? Okay, so we have some questions then. You want to run through some of this? Yes? Where would you like to start? Amy? Sure. So here it says we're going to be using the unit circle to do this. So I'm going to start first by figuring out what quadrant I need to be looking in for my answer. So we're told that our answer needs to be between pi and 2 pi. So if I go around, there's 0, pi over 2, pi, 3 pi over 2, 2 pi. So from pi to 2 pi covers quadrants 3 and 4. Does that feel okay? And then from chapter 2, I remember that all silly turtles crawl was an acronym we used to determine where sine, cosine, and tangent is positive or negative. So the A tells us that in quadrant 1, all of sine, cosine, and tangent are positive. The S in quadrant 2 tells us sine is positive, so cosine and tangent are negative. The T in quadrant 3 tells us tangent is positive, so sine and cosine are negative. And the C in quadrant 4 tells us cosine is positive, so sine and tangent are negative. Is okay with that? In our situation, tangent is negative, so I know my answer needs to be in quadrant 3, because that's the only quadrant where both of these two things can be true. So far, so good? Oh my goodness. That is supposed to be quadrant 4. I put it in the right spot and I wrote down the wrong thing. Why? I don't know why. So that's the angle that we're looking for, right? So far, so good? So now I remember that tangent is y over x. So I'm going to go to my unit circle and look in quadrant 4 for a coordinate pair where I take the y coordinate divided by the x, I get -1. So that has to be right here. Right? -2 root 2 divided by +2 root 2 has to be -1. That's the only spot in quadrant 4 that satisfies that. So then I read the angle measure off the unit circle for that point. 7 pi over 4. That is my answer. Does that feel okay? So I wrote down a lot of stuff. You don't necessarily have to write down everything that I wrote down, but again, in an effort to try to show you some work, to talk you through the reasoning that I'm using. I wrote down a lot of things, but like mostly what I did is I just read the answer from the unit circle. I just had to justify where to look, right? Should we do some more? Who would like to, what other one would you like to talk about? Or one's Lily?
11.
11, okay. All right. So I'm going to go and draw my picture first. So 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. So 3 pi to 4 pi is quadrants 3 and 4. Cool there. Then we'll do all silly turtles crawl. If I look at tangent, where is tangent positive? Q1 and Q3. Everybody's cool with that? So the angle that I'm looking for is in Q3. Okay. Tangent I know is y over x. But here's where things go off the rails a little bit, because when I go to the unit circle, I don't see any coordinates that have just a 3 in anywhere, right? I see 1, I see 2, I see root 2, I see root 3, but I don't see any regular 3s, right? So what I'm going to do is I'm actually going to reduce this fraction. So regular 3 is the same as root 3 times root 3. So I'm going to actually reduce that to 1 over root 3. And now I'm going to go look on the unit circle for a place in quadrant 3 where the y coordinate has a 1 and the x coordinate has a root 3. So I'm looking at 7 pi over 6. However, that is not my final answer. What's wrong with that? Yes, it's not inside of the range. So what am I going to do to that?
You're going to have to go around to find a coterminal angle.
Exactly. We'll find an angle that's coterminal to it that is in that range. Now, is 7 pi over 6 too big or too small? Too small, right? That's certainly less than 3 pi. So should I be adding 2 pi or subtracting 2 pi? Adding 2 pi. So to add those two fractions, I need to make a common denominator. That gives me 19 pi over 6. And that is in between the range. FYI, you can check these on your calculator. So to check this, what I would do is I'm going to do tan of my answer, 19 pi over 6, to make sure that that gives me root 3 over 3. So that's what 19 pi over 6, or tangent of 19 pi over 6 is. And that's root 3 over 3, which is the same value. But I should also check to make sure that 19 pi over 6 lies between 3 pi and 4 pi. So 3 pi is 9.4 yada yada yada. 19 pi over 6 is 9.94. That's good so far, right? Bigger than 3 pi. And it's definitely smaller than 4 pi. So that answer looks great. Again, you don't have to do the calculator thing at the end that I did as a check, but it's helpful to have a way to check these, right? Pretty easy to do it. It's all done on the, can all be all done computationally on the calculator to check it. Basically just plugging your theta back in to make sure it satisfies the equation, and then check to make sure it falls inside the desired range. Want to do another? Amy. Okie dokie. So one thing jumps out at me right away on number 12. It's because we have a cosecant here, not a sine or a cosine or a tangent. Well, that's okay. I remember that cosecant is the reciprocal of sine. Everybody's okay with that? So 1 over sine theta is equal to negative root 2. And then I can, to get sine theta, I'm just going to do the reciprocal of both sides. If I flip both sides, it's still going to be the same thing. It's okay to do that because I know that both of these are non-zero. So sine theta is negative 1 over root 2. And I would probably rationalize that denominator because, again, that's not a value I recognize on the unit circle. But after I rationalize it, it is. Is that okay with everybody so far? So now this is reconciled into a fairly familiar looking problem. I'm now going to look at the interval and figure out the quadrants I have to be working in. So 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, 5 pi, 11 pi over 2, 6 pi, 13 pi over 2, 7 pi, and then 15 pi over 2. So we're looking at from 13 pi over 2 to 15 pi over 2, quadrants 2 and 3. And then if I go to all silly turtles crawl, the place where sine is negative is in Q3 and Q4. So here we're definitely operating in Q3. Cool with that? So far, so good? Yeah, Zach?
How do you know that it's negative in 3 and 4?
So A is all of them are positive. S is sine is positive. T is tangent is positive. C is cosine is positive. Anything that's not listed as positive in that quadrant has to be negative.
Okay, that makes sense.
You're welcome. Okay, so I have that. So I'm going to go to my unit circle and find the place where sine is, or where, well, sine is the y coordinate, right? So I'm going to find on my unit circle in quadrant 3 where the y coordinate is negative root 2 over 2. So right there, 5 pi over 4. Everybody okay there? Is that our answer, though? No, why not? It doesn't fall in the range. Is it too big or too small?
Too small.
Too small. So I'm going to be adding 2 pi. How many times am I going to have to add 2 pi? Well, let's think about it here. To get there, we go around once, that's at 2 pi, twice to 4 pi, 3 times to 6 pi, and then around to our answer. So I went around 3 times. So I'll be adding 2 pi 3 times.
How do you make it out of 3 times?
So just when I drew this, I crossed 1, 2, 3 times. When I drew the standard position angle. Is that okay?
Let me rephrase this. How do you know? It's more about how do we know we have to add it 3 times in order to get it?
Okay. So I'm trying to get to the terminal side. And that terminal side lies between 13 pi over 2 and 15 pi over 2. Okay? So I'm going to start here at 0. Now I've gone to 2 pi. Then I've gone to 4 pi. Then I've gone to 6 pi, 6.5, 7 pi, answer. So if I count how many times did I have to go around, 1, 2, 3 times I had to go around before I could get to my answer.
Okay.
Does that feel better?
Yeah.
Okay. Zach?
You know to stop at 7 pi because that's like the unit when it's 13 pi over 2.
Right, because I passed 13 pi over 2 to get to 7 pi, so I know that was my last time around.
Okay.
Is that okay, everybody? So I make some common denominators here, and what does that give me? 29 pi over 4. And you could check that if you want, but I promise that it works. Is that okay? Alternatively, you could just kind of guess and check it, right? You could just figure out what that lower bound is and keep adding 2 pi until you got past it. You know, you could do it that way too. But I figured I'd draw the picture already. You know, might as well use it. Amy.
So then just to clarify, you always add 2 pi because that's the value when you go around one.
So if you're going to find something coterminal, you're going to either add or subtract 2 pi depending on whether you're trying to find a number is your angle too big or too small, right? If this was like negative 15 pi over 2 to negative 13 pi over 2, we'd be subtracting to get down inside the range. But it would be obvious, I think, when to add or subtract, right? You're welcome. How do we feel about this homework assignment? Better now? Fairly easy, right? You're basically just figuring out the quadrant and then looking it up off the unit circle. It's not so bad. Little bit of practice and you'll get pretty good at it. All right. Let's talk a little bit more about some other topics in 4.1 that I wouldn't have expected you to get to yet. Okay? So, what if we're asking to solve one of these trigonometric equations that doesn't involve the unit circle, right? Yes, Drake? What's up?
I was just going to say we're probably going to end up graphing it, or like graphing a line and making a triangle.
No.
Oh, these are negative. These are the inverses, so they wouldn't be possible.
Yeah, just look at some examples and we'll kind of show you the way that I would suggest doing this. Hello. How are you? Just dandy. Loretta, it's for you. You're welcome. Okay. How do I know immediately from looking at this that I can't use the unit circle on this problem? Well, look at the value that sine theta equals, right? Is that a unit circle value? Yes. It's a decimal, right? So right away we're not going to be able to use the unit circle on this. Cool? Okay. So what I'm going to start by doing is drawing my XY axis and figuring out what quadrants our solution set can lie in. So I have 0, pi over 2, pi, 3 pi over 2, 2 pi, and then 5 pi over 2. So going from 3 pi over 2 to 5 pi over 2, we're going to be in quadrants 1 or 4. So far, so good? Okay. And then using all silly turtles crawl, sine is negative in which one of those two quadrants? 1 or 4? 4. So I'm going to draw in the terminal side of my angle. And then I'm going to draw the standard position version of that, which is here. That's my angle theta that I'm looking for. Is everybody happy so far? Haven't done anything weird yet, right? Next, I'm going to label this angle that I make the acute angle between the x-axis and the terminal side of my theta. I'm going to call this alpha. That's that little fish symbol there is the Greek letter alpha. And what I'm going to want to do is to describe a relationship between theta, alpha, and the x-axis, so 2 pi. How are those three values related? Aiden?
Well, theta plus the other one is equal to 2 pi.
Very good. So if we look, if we go from here to here, that's theta. If we go that much more, that was alpha, and that gets us to 2 pi. So to solve for theta, I need to do 2 pi minus alpha. So the question becomes, how do I find alpha? Well, alpha is just going to be, in this case, sine inverse of the absolute value of negative 0.55. And I can do all that on my calculator. Notice that in my calculator, instead of using the absolute value operation on my calculator, I just did the absolute value in my head because it's like way less buttons to press. So I have 0.57 0-ish as my solution. Let's just double check that. So sine of that answer better give me negative 0.55, which it does. And it better lie between 3 pi over 2, which it's bigger than, and between 5 pi over 2, which it's smaller than. So I am satisfied that this answer is correct. So far, so good. Okay, let's do another example. Yes, Zach.
How did you know that theta and alpha equal 2 pi?
From the picture I drew. So again, if I follow this, this is much as theta, right? And then this much is alpha, and that ends at 2 pi.
Okay, that makes sense.
Okay. So let's say we want to find cosine theta equals negative 0.86, or theta is between 3 pi and 4 pi. So we'll start by drawing our picture. 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. So we're looking at this section down here. Using all silly turtles crawl from quadrants 3 and 4, which one is cosine negative in? Quadrant 3. Everybody good with that? So I'll put in my terminal side. So if I do this and I draw my standard position angle, that's my theta, right? Notice I had to go around more than once, because I had to get between 3 pi and 4 pi. So far, so good? Okay. Next, I'm going to label my angle alpha. Remember, alpha is the acute angle between the x-axis and the terminal side. So that's this angle here. Everybody good? Now let's relate theta, alpha, and 3 pi together. So here to here is 3 pi. There to there is alpha. And that's ending at theta. Can we see that? So theta is 3 pi plus alpha. Aiden?
Did you do it differently where you just like put it into a smaller thing, we just do it pi plus alpha and then add 2 pi like afterwards.
Same thing. Yep, same thing. Yes, sir?
Okay, how does, I didn't catch that where you had, like, you form that function where pi, or, excuse me, theta equals 3 pi plus alpha.
Mhm.
So,
So look at the highlighted blue part. So there to there is 3 pi, right?
yes.
And then the purple section here is alpha. And that ends at the terminal side for theta. So theta is 3 pi plus alpha. Is that okay? Amy? Sure. Now, alpha in this case is going to just be cosine inverse of the absolute value of negative 0.86. So it's calculator time. 3 pi plus cosine inverse 0.86. Again, notice I didn't bother with the absolute value in my calculator, I just did it in my head. And that gives me 9.96. And again, we can check that if we'd like. Oops. Cosine of that answer is negative 0.86. And 3 pi is smaller, just barely, but smaller. And 4 pi is definitely bigger, so we're good to go. Okay. So notice in one of these examples, we wrote, our equation was theta equals the x-axis minus alpha, and the other one it was the x-axis plus alpha, right? It'll always be one of those two equations. Here's the way that you can figure out which one of the two it is without really having to look at your picture. Okay. So if theta is a positive angle and the last axis you passed in drawing your standard position angle was a vertical, you're going to be subtracting. If theta is a positive angle and the last axis you passed on your way to the terminal side is a horizontal, you'll be adding alpha. That's fine. What do you think is going to happen if theta is negative? They're reversed, yeah. So if the last axis passed is vertical, you'd add. And if the last axis passed is horizontal, we'll subtract. Or you can continue drawing your pictures and writing your equation from your picture. That's fine too. Some of us that's easy. Some of us, that's a big challenge, and this becomes quite a bit easier. So either way of thinking about it is fine. We'll write it down so that you have it. If you want to use it or want to construct your equations this way, that's okay. If you prefer to just kind of look at your picture and go, yeah, no boy, that's okay too, right? Both are doing the same thing. Zach?
Do you have to draw it to know if the last x is passed with circle or one time?
Yes. Yeah. You really do need to draw it to get that part.
Okay.
Let's do one more example like this and then we'll move on. Does that sound okay to you guys? Let's see. Nope. Gotta be a big number. Oops. Gotta be that order though. Let's say we want to find secant of 2.5, where theta is between, sorry, secant theta equals 2.5, where theta is between negative 4 pi and negative 3 pi. So we draw our picture to start. 0. Now since they're going negative, which direction are we going? We're going clockwise this time. So negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2, negative 3 pi, negative 7 pi over 2, and then negative 4 pi. So going from negative 3 pi to negative 4 pi, we're dealing with quadrants 1 and 2. Is that okay, everybody? Notice that we're going the opposite direction because we're dealing with negative angles. So far, so good? Now, remember that secant is just the reciprocal of cosine. So this is equivalent to cosine being 1 over 2.5. So far, so good? Which quadrant is cosine positive? Quadrant 1 or quadrant 2? 1. So I'll draw my standard position angle. So again, notice we're going clockwise because we're going negative. We had to go around one time before we went ahead and went back to our terminal side. Everybody's good with the theta we've drawn? Okay. This guy in here is going to be my alpha, as always. Again, the acute angle formed between the terminal side and the x-axis. Since we know that theta is negative, because it has to be between negative 4 pi and negative 3 pi, theta is definitely negative. Everybody's good with that? And the last axis we passed was the vertical right here. According to my criteria, what is the equation we're going to write? Is going to be plus alpha. So theta equals negative 4 pi plus alpha. And what's alpha going to be this time? Cosine inverse of the absolute value, 1 over 2.5. And now it's calculator time. Is this feeling okay, everybody? if there's something you need clarification on or have a what if question or whatever, feel free to ask.
I have just one quick what if.
Sure.
So if you have like a sine function or something that somehow like goes into the, for the silly turtles thing, and goes into the quadrant 2, would that make a alpha, like whole alpha function, like a subtracted instead of additive, like what we were doing here?
So it depends on this piece, whether alpha or whether the alpha is going to be added or subtracted, as to whether the angle theta that you're looking at is going to be positive or negative.
All right. Okay.
So it depends on which way you're going around to get to your theta, whether you're going clockwise or counterclockwise. So just what you described, I can't answer that. Both could happen depending on which way you're spinning. Is that okay?
Okay.
Jack?
Just a clarification. So for your equation that you're writing,
Yeah.
for the negative 4 pi, that's just you choosing the lowest value in your set, correct?
Well, it's when we draw the x-axis or the side of alpha that's on the x-axis,
Okay.
that's where I'm coming up with that
Okay,
number.
thank you.
Is that okay?
Yeah.
So sometimes it could be one end, sometimes it could be the other end from the interval. To me, that part I never think about. It's just like when I draw my picture, it's the part of the x-axis that I'm using to make my alpha. Does that feel okay?
Yeah.
So what was this? This was 11.407. And again, if I wanted to check that, I am getting 1 over cosine to be positive 2.5. And if I check the interval, that's definitely it's definitely bigger than negative, or smaller than negative 3 pi, right? That's going to be negative 9 something, so this is smaller. And it's definitely bigger than negative 4 pi, which is going to be negative 12 something, which this is bigger than, so I'm good. Is everybody okay there? Okie dokie. All right. So let's cover a couple of miscellaneous things that we haven't mentioned yet, but you would have read these in the note or in the section or whatever. So we've talked about the sine inverse function, right? We've been using these inverses. There's an alternative notation that's a little bit older, but still used a little bit, called arc sine. Same thing as sine inverse. You can think about it the same way. And then that works, or that exists also for cosine and tangent. Oops. So if you see arc in front of something, it's just basically the inverse. Does that feel okay? So that's just a little bit of notation. So here's a tricky question. What is tan inverse of tangent of 5 pi over 4? Drake?
If you want to convert that to arctan, that would be pretty sure arctan parentheses. Like the left side would, outside of the two parentheses, will just first and foremost just be converted to arctan.
You can do that if you want. It doesn't. That part doesn't really matter there. Mia?
They cancel out.
So you'd think it's going to be 5 pi over 4, right?
I don't know.
That's the obvious thing to state. That's unfortunately not correct here. So why is that not what happens? So remember, for these inverse functions, they have specific domains and ranges. So for sine, the domain is -1 to +1, and the range is -2 pi, or pi over 2 to positive pi over 2. Cosine has the same domain, but its range is from 0 to pi. And tangent's domain is all real numbers, but its range is -pi over 2 to positive pi over 2. Notice that those are parentheses on the tangent, not brackets. Why does the -pi over 2 and positive pi over 2 get parentheses there for tangent rather than brackets? Right, why would they not be included though? Think back to the graph of tangent. What happens at -pi over 2 and positive pi over 2? Edmund?
The asymptote.
That's where the asymptotes are, right? So there's no point there. So you can't give back a, if you think about what the inverse is doing, I should be able to give you undefined and you'd have to give me back an angle measure. I can't do undefined and give you back an angle measure. That's nonsense. There's no point there, right? So I know that tan inverse can't give me the value of 5 pi over 4 because it's outside of the range. Is that okay? So how would you want to do this then? Well, tan inverse tan 5 pi over 4. I'm just going to go to my unit circle and evaluate 5 pi over 4. So 5 pi over 4 is 1 on my unit circle. So really I'm doing tan inverse of 1. So which quadrant should I be looking in? If it has to be between -pi over 2 and positive pi over 2? I'm looking on this side. So we're talking in here. Is that okay?
Is that supposed to be an alpha or?
Doesn't, no, it's not, we're not using that. We're just pointing out what angle we're finding. So I just go back to my unit circle now and I look in quadrant 1 for the place where x and y are the same. That's at pi over 4. So just use the unit circle again. So that's the place where you have to be a little bit careful on this, right? If we're solving an equation for theta, we can get values of theta outside of the range of my inverse. That's fine. But if we're just evaluating an inverse, has to have a value in its range, right? They're two subtly different questions. Does that make sense? Okay. And then there's one other kind of question that can pop up in the, or pops up in the bookwork that I'm going to ask you to do. So let's say we're asked to find an algebraic expression for sine of arc cosine of 2x. So the trick on a problem like this is you're going to want to work from the inside out. So arc cosine, or any inverse trig function, gives us an angle measure, right? Everybody's clear on that? If I do the cosine of both sides, that's equivalent to being cosine theta equals 2x. Everybody's okay with that? And so if I use my right triangle definition of cosine, I can think of a right triangle with some acute angle theta, whose adjacent side is 2x, and whose hypotenuse is 1. Everybody okay with that? So now that I've done that, this piece really becomes sine of theta inside the triangle that I've just built. Which is opposite over hypotenuse, which is going to be something over 1. Everybody's okay with that? How am I going to find that something, that opposite side? The Pythagorean theorem. So just for the sake of argument, I'm going to name that opposite side A. So I can say a squared plus 2x squared equals 1 squared. Everybody happy there? Notice the hypotenuse is the C in the Pythagorean theorem. So 2x squared is 2x times 2x of 4x squared. And then I'll subtract 4x squared from both sides. And then we'll square root both sides. Notice I dropped the plus or minus and just made this positive. How do I know to do that?
The length.
It's a length of a triangle, so it has to be a positive. And then can I simplify this and just call this like 1 minus 2x? No. Why not? Yeah, you can't break a radical at an addition or subtraction symbol. If you're ever unsure about whether you can do something like that, what you can do is take this and plug in some value for x, and then take this and plug in the same value of x and see if you get the same answer. Has to be like a non-trivial value. But for example, if I just use 2 for x, I get a non-real answer here. I get an error. And if I do the other side, clearly it's not going to give me a non-real answer. Oops. What is going on here? Right? So that's bad. So this is as good as you can do. So sine theta is going to be square root 1 minus 4x squared over 1. Or just square root 1 minus 4x squared. Yeah, it's essentially turns out to be our final answer. Amy.
So then you can't get rid of the square root because the 1 is the square as well as the 4?
No, because of the subtraction symbol in between them.
Okay.
That's the issue. if this was 1 times 4x squared, then yes, that would simplify to 2x. But if it's 1 minus or 1 plus, no bueno. Is that cool?
Because the other side isn't also a square root, and
No.
it's not like two sides of the equation.
It just, you can't break a radical at an addition or subtraction symbol. Right, like 4 square root of 4 plus 9 is not 5, right? Or it's not 2 plus 3. Because this should be the square root of 13, which is definitely not 5. Right? If we draw it, if we write it that way, it makes a lot of sense, right? You're like, oh yeah, of course. Sergio. Certainly. What do you guys think? This seems like a good place to stop, right? Okay. So let's worry about worksheet 2, and then the problems 1 through 18 from the problem set you should also be able to do. For Sunday, let's worry just about worksheets 1 and 2, though. I think that's probably enough for Sunday's problem set. The other homework problems we'll just push into next week's. Feel okay to you guys? I think that's good.
I kindly ask that we don't have a homework quiz on Monday because it's
Yeah, I can agree that.
Sure, that seems okay.
So these questions are worded differently than what we had on the notes, but so like you have
Oh my gosh, I'm so hyped up. Oh my god, yeah.
0.56.
Yeah, my cousin does.
Now we're looking at like it's less than less. So I went ahead and took a look at the key briefly just for number 1. And I saw that like while we did follow the steps like as we did in the other thing with the range. So yeah, that's what my other question earlier was referring to. So, because this crosses because this crosses the line.
So when you're drawing this, the last axis you cross is the vertical. So you're going to be
That's why
subtracting.
it's negative. Okay. Now that I have 2 pi
Yeah, and it
3
should be
pi, whatever axis, y value would axis that this would end up on, I would get the terminal, the value that coincides with like
so you're
either
looking
one
at
of those.
this space, right?
Yeah.
And
That'd be
cosine is
5 pi over
positive
2.
here. Yeah, but that doesn't really matter up there. Yeah.
Okay.
I must stress.
So cosine is positive in the first quadrant. So you're going to be looking at that for your theta. Since the last axis you passed was horizontal, it's going to be 2 pi plus alpha.
Okay.
Does that feel okay?
Yep.
Okay. Feel free to come back up if you want to talk some more.